Every rule you give an AI lives in the chat thread. You hit the context limit or open a new one, it's gone. It forgets your architecture, contradicts itself, and breaks code that had worked. You can't even tell the difference because nothing wrote down what you had asked for. Spec-Driven Development fixes that. You write down what the software should do before the AI writes any code, and that spec lives in your repo, not on a chat window. The AI reads it, works the checklist, and changes only what you had specified. I'm going to show you both half of the problem. First, a greenfield project, a Python CLI calculator built from an empty folder. Then, a brownfield one, an existing Express microservice with two endpoints /API users and /API events already in it, and zero specs anywhere. Let's start with the greenfield project. This is going to be a Python CLI calculator. Let's start from nothing. It requires OpenSpec, so we will grab the command from the OpenSpec installation page. We will install it through the Node Package Manager, create the directory, and navigate into it. Right away, we will initialize the OpenSpec. Once we initialize the OpenSpec, you will notice it supports 34 AI tools. In this video, we will be using the Claude code. Once you make this selection and hit enter, you will notice the .cloud directory getting created. If we inspect this directory, it contains two primary directories, the skills and commands. Skill.md file is nothing but instructions that used by Claude when you execute OpenSpec commands. As you can see, OPA6 commands are already available for us to autocomplete in the Claude session. Here is the part that matters. I am not typing build me a calculator. I am proposing a structured changes using OPA6 propose command with one line describing what it should do. And it ended up creating the four main artifacts: propose, spec, design, and task, as you see in the right side tabular column. This is where you are the architect. I am opening the spec and adding a rule the AI never suggested. A division by 0 returns a clean error message. It does not crash. Now, OPA6 apply. The AI reads our spec, not our vibe coding window text, and writes the Python to satisfy them. Claude refers the skills and commands directory to implement the spec we created in the proposal step. As you see, it ended up creating the code base, and after few prompts asking our affirmation, the result is the complete code base with tests as well. Let's ask the Cloud how to run the Python file and verify it. Watch the verification in the new terminal window. The 2 plus 2 gives us 4. The 10 divided by 0 gives us the exact error that we asked it to produce. That's the line we wrote in the spec showing up in the output. OPA6 archive is the last command in our greenfield project. Along with the archive command, we will ask the Cloud what files and folders are going to change. This archive command moves the finished change into archive directory. It also merges its spec into OpenSpec specs directory. Now the repo carries a written record of what it does. If you see the last tabular column, it describes which folders have moved from one place to another. Let's do a quick recap of our greenfield project. We started with the OpenSpec initialization command followed by the propose, which created 4 important artifacts. We used the apply to implement the spec and artifacts. We finally did the archive command to archive the feature. Let's start with the brownfield project. Here is an existing Express service, users, events, and an SQLite database. It has no specs, no documentation, nothing. The kind of repo you actually inherit. It runs on port number 3000 with user and events endpoint. In this brownfield project, I want to add a health endpoint without touching any of it. Let's see what the repo does. We will start the server on port 3000. And if you see, the users gives us result, but not the health endpoint. It's the same first step, OpenSpec init. 5 seconds later, the legacy repo is now spec-driven. Before we propose our change, notice that OpenSpec command created the command and skills directories here. If you see, OPSX commands are now available for us in the Cloud CLI session. Then OPSX propose add health check. Notice it reads the code base first, and it works out on its own that this is an Express and SQLite service, and that GAD/health should report both service and database status. As you see, it already referenced us the 4 important artifacts. Let's ask the cloud itself what files it created. And if you notice, the design.md wasn't created because this is a minor change. Apart from that, 3 other artifacts were created. And here is the brownfield difference. This is a delta spec, added, modified, removed. Only the slice we are changing gets documented. /opsx apply writes the root. Then it verifies properly. It actually breaks the database permissions to force a real 503 instead of just claiming that it works. After answering few prompt questions, it has implemented the health endpoint now. Let's ask the cloud the files it created as part of the apply command. Now OPSX archive and the specs will move into the archive directory. If you notice the terminal, the edits or changes in the files are only against the health check and not against the existing code base. That's because we wrote the spec just for the health endpoint. Let's verify the health endpoint. The server is running and the health endpoint now returns us valid output. Let's do a quick recap of our brownfield project. We started with OpenSpec init command followed by propose. It referenced us 4 artifacts, but the design wasn't created because it's a minor feature. We applied the spec followed by archiving it. If this was a bigger project with a large code base, we are supposed to run the OPSX explore. It's the same chain just after the OpenSpec init command. The OPSX propose writes only the delta spec that is added, modified and removed. These are the only slices that you're changing, and these are the only things which will get documented. The agent can't invent requirements on top of the code that already works.